Welcome to this explainer. Have you ever stared down a massive enterprise database and just felt, well, totally lost? Like you're standing in the middle of a sprawling, chaotic metropolis with absolutely zero maps? It is incredibly overwhelming, right? Well, today, we're going to explore how a suite of tools hosted at rossdata.dev acts as the ultimate master map, designed specifically to help you navigate the massive architecture of the Ross ERP 8.0 database schema. Trust me, it's going to completely change how you view and interact with this complex system.
Okay, let's kick things off by just wrapping our heads around the sheer scale we're dealing with here. Imagine trying to memorize the layout of a city that has 1,840 distinct, highly complex structures. That is exactly what we are looking at. 1,840 base tables making up the core foundation of the Ross ERP system. But wait, it goes so much deeper than that. Zoom in on those tables and you'll find an overwhelming 36,230 distinct columns. That's over 36,000 individual data points, and each one has its own specific rules, relationships, and purposes. Trying to keep track of that in your head or, digging through old school static manuals, you'd need a serious amount of coffee. And honestly, it's practically impossible. And to actually tie all that static data together, move it around, and make it function for the business, you've got 244 complex procedures running behind the scenes. When you look at these numbers side by side, it becomes immediately obvious why trying to decode this database without a modern, dedicated toolchain is just a massive headache. So, to make sense of this massive data metropolis, we'll be breaking things down into 6 key areas in this explainer. First, the vanilla schema challenge. Second, the data dictionary foundation. Third, mapping the knowledge graph. Fourth, navigating programs and facilities. Fifth, powering automation and AI. And finally, customizing your own private instance. All right, let's dive into part 1, the vanilla schema challenge. The most crucial point to grasp right out of the gate is what we mean by the vanilla schema. Basically, we're talking about the standard base data model exactly as it ships from the vendor. This covers the financial and manufacturing modules, fin and man. It represents the out-of-the-box state, completely untouched, before any of your company's unique, site-specific customizations are added on top. It is the absolute blank canvas that everyone starts from. Moving right along to part 2, the data dictionary foundation. If the database is our sprawling city, the data dictionary at d.rossdata.dev is your ultimate street index. It's a completely interactive reference for the whole vanilla schema. You can search every single object, tables, views, procedures, you name it. You can drill all the way down into specific column details to check things like nullability, primary keys, and valid values. It tracks foreign keys going in and out, maps field-level lineage so you actually know where a column is read and written, and it even generates entity relationship diagrams for every table's little neighborhood. In my absolute favorite feature, boom, one-click exports. You can grab exactly what you need in CSV, JSON, or instantly copy the DDL statements. Think of it this way, the data dictionary is your exhaustive text-based street index, perfect for getting into the granular weeds and pulling exports. But the knowledge graph, that's your satellite view. It's a visual, relational tool designed for pathfinding and seeing the big picture. They are 2 totally different lenses, looking at the exact same data set. And the best part is, they are completely interlinked. Which brings us to part 3, mapping the knowledge graph. Over at kg.rossdata.dev, you don't just read the schema, you literally get to see it. This is a force-directed map of the schema and code layer that groups objects into modules and communities. Ever need to figure out how table A connects to some distant table B all the way across the database? The pathfinding feature will trace that exact route for you. It automatically detects central hubs and highlights the most connected nodes. And because it's a two-way street, you can just click on any node in the visual map and jump right back to the data dictionary for the text-based details. Up next, part 4, navigating programs and facilities. So, how does the user actually interact with all this on the application layer? We have 2 primary exploration tools. The Facility Explorer looks at things from the user's side. It maps out 2,327 user-facing screens and reports, giving you the full menu path to reach any facility. Meanwhile, the Program Explorer is your back-end catalog. It maps over 3,300 programs and cross-links them to the exact tables they reference, boasting an incredible 24,363 program-to-table links. Working together, they connect exactly what the user clicks on their screen to what the database is actually doing behind the scenes. And hey, it's not just us humans poking around the system, right? We've got other applications connecting too. For integrating different software systems, the Web Services Catalog is an absolute lifesaver. It clearly lays out all 233 SOAP and Connect services across 10 different systems. It gives you typed parameters and the full request and response field lists, all built directly from the real data dictionary columns. It completely takes the mystery out of the integration layer.
That leads us perfectly into part 5, powering automation and AI. This is where things get really fun. It all starts with the Rust API. This is a public, read-only JSON API for the data dictionary. It lets you fetch schema data, look up columns, or grab DDL programmatically. And the best part? No API key is required. You can plug the entire vanilla schema straight into your own tools, scripts, and automated workflows right this second.
But we can take it way further using the provided MCP server, which stands for Model Context Protocol. Think of this as a direct bridge for AI agents. An AI can autonomously use this server to execute these exact steps. First, it looks up tables and columns using the dictionary endpoints. Second, it traverses relationships and finds paths using the knowledge graph logic. Third, it identifies the referencing screens and programs via the application layer. You're basically giving an AI the ability to explore the database exactly like a senior engineer would. And pretty soon, you won't even need to write any code to harness that AI power. A feature called Ask Ross is coming, and it will give you plain English answers about the data model. You literally just type something like, which table holds GL postings and how does it link to the subledger? The tool will do the heavy lifting, retrieve the exact tables and relationships, and hand you direct links back to the dictionary and the graph. It turns this massive, intimidating schema into a simple conversational experience.
Finally, we hit part 6, customizing your private instance.
Look, we've been talking about the vanilla base this whole time, but if you work in enterprise software, you already know the reality on the ground is way messier than the out-of-the-box standard. Over time, every single deployment drifts from that base model. Your environment accumulates custom tables, vendor layer overrides, site-specific fields, unique triggers, you name it. You have custom integrations that the public vanilla tools just aren't going to see. The standard map is awesome, sure, but it doesn't show the new roads and buildings your specific company built.
So, this leaves us with a pretty critical question to chew on as we wrap things up. Your Ross ERP isn't vanilla anymore. Are you ready to map the system you're actually running?
You don't have to stay in the dark with your own undocumented customizations. You can actually get a private instance of the data dictionary, the knowledge graph, the REST API, and the MCP server built around your exact customized data. It stays yours and it's never published. Just reach out to ross@ryanbrents.com to get started. So I'll leave you with this final thought to ponder. If a database is quite literally the lifeblood of your entire business operations, but nobody can easily read or navigate its true map, who is really in control of your data? Thanks for hanging out with me for this explainer, and happy mapping.